code word is to consist of two distinct English alphabets, followed by two distinct numbers, between, underline the word between, I will tell you why, between 1 and 9. Full stop. How many such codes are possible? How many such codes are possible? Okay, let us understand the question first. Okay, I need to understand the question first. A code word, first two should be alphabets only. Followed by means the next two should be the numbers only, and that number should be between 1 and 9. What do we understand by the term? Understand the term between. You should know the difference between from 1 to 9 means what? 1 also was included, 9 also was included. That was the word from. Now the word between. Between means what? 1 is not there, 9 is also not there. How many numbers are there in between? How many numbers you are getting in between? Yes, I want a message. How many numbers are there between 1 and 9? How many? 7. Yes. Okay. So from 7 you want two distinct numbers. Okay. Yes. So how should be the arrangement now? First two should be alphabets. Second two should be numbers. So how many are possible? How many alphabets do we have? So my answer is, okay, answer is, how many alphabets? 26. So from 26, I want 2. And followed by, now there are only 1 and 9 is not included. From 7, I want 2 numbers. Okay. Yes. So this is 26p2. 26p2 is 26 into 25, 2 times, into 7 into 6. Yes, give me the answer. Are you getting this answer? 27,300. Yes. Okay. When a group photograph is taken, when I write, I want you also to write. Please do write the question as well as the answer. Okay. So when a group photograph is taken, comma, all the 10 teachers should be in the first row. All the 10 teachers should be in the first row with the principal and vice principal. With principal and vice principal in the middle. In the middle. Full stop. The 18 students will be in the second row. The 18 students will be in the second row with the two leaders. At the extreme. at the extreme. Full stop. How many arrangements are possible? How many arrangements are possible? Okay, first let me explain to you the question. Okay, so the question tells me when a group photograph is taken, all the 10 teachers. Now remember, in this 10 teachers, principal is also there, vice principal is also there, but condition tells us they have to be in the middle. Okay, so in the first row, all the 10 teachers with the principal and vice principal in the middle. With the principal and vice principal in the middle. Okay, so let me draw and explain it to you so that the idea will be clear. Okay, so let us take the first row. Okay, let us take the first row. Once you understand the question, then the answer is easy. Answer is only one step there, but you need to understand the question. Okay, so now suppose I mark this as the first row. Okay, I mark this as the first row. Fine. So in the first row, how many total? 10 teachers. Okay, yes. So that means here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 teachers. Among them, principal and vice principal has to be in the middle. Okay, so here let us see if principal and vice principal can come here. Principal and vice principal. Yes, so they have to be fixed. In the middle means what you think? You just think they are fixed here. They are fixed there. Okay, so now these are in the middle. Check whether they are in the middle for this side and for that side. They are in the middle, no? Yes? Okay, so now check how many arrangements are possible. So this is the first line. This is the first line. Okay, let me come to the arrangements a little later after I'm arranging the second line. Now the second line they tell the 18 students are there. So is the first line clear? Anybody wants me to repeat the first line? This first line, anybody wants me to repeat the first line? In the first line it is told there are 10 teachers. Among the 10 teachers, principal and vice principal should be in the middle. So I just put a circle for them such that they are in the middle. So for this side and for this side teachers are there. So that is the first row. Now the second row is telling me there are 18 students in the second row. Okay, so there are 18 students in the second row where the two leaders are at the extreme. Extreme means what? Extreme means at the side. At the sides. So now suppose this is the second row. Here what they are telling is here one leader will be there. So I call L1 and here one leader. They have to stand at the extreme. Extreme means ends. So leaving the two leaders, how many students are here? How many students are here? There are 16 students. Is this much clear? Is this idea clear so far? Yes, is the idea clear? Yes. Okay, so now let us speak about the arrangements. Let us speak about the arrangements. First, let us see the first row. In the first row, how many teachers you can find? 1, 2, 3, 4, 5, 6, 7, 8. Remember, principal, vice principal can't they change their places. So I put that fixed. I put them in one circle there. Okay. Yes. So it is not told that principal has to be here in the first and the vice principal in the second. That is not told, but it is told that principal and vice principal has to be in the middle. So I just marked one circle for them to be in the middle. Okay. So how many ways you think this first row could be arranged? Yes. Any ideas? How many ways you think the first row could be arranged? Yes. It is 8 factorial into 2 factorial. 8 factorial into 2 factorial. Yes? Okay, correct. Okay, so this first row could be arranged in 8 factorial. Now 8 factorial is why, say I can see 8 numbers. Into 2 factorial. Why is this 2 factorial? Because that vice principal and principal can change their places. No? They can be arranged themselves. So it is 8 factorial into 2 factorial. That is the first row arrangement. Now, can anyone tell me the second row arrangement? The second row arrangement. Can you tell me the second row arrangement? Anyone? Yes, it is. There are 16 students, 16 factorial into the 2 leaders also can change their places, no? So it is 16 factorial into 2 factorial. So together, what is the arrangement now? So together, the arrangements are, so total, so what is given? How many arrangements are possible? So therefore, arrangements are 16 factorial into 2 factorial. So this is the second row arrangement into first row arrangement, 8 factorial into 2 factorial. Yes, this factorials are big. If possible, get the answer. Otherwise, keep this answer as it is. Is it possible to get this answer? In how many ways? In how many ways the letters of the word accountant, ACCOUNTANT, the letters of the word accountant be arranged. Question mark. In how many of them vowels are always together? Okay. Now, what you do is look at that word accountant and quickly keep ready which letter is repeated how many times. First, look at that word accountant and keep ready which letter repeated how many times. First, we need to have that for the arrangement. Yes, is it ready? Come on. A is repeated how many times? 2 times. C is repeated 2 times. Next, which is repeated? N. N is repeated 2 times. T is repeated 2 times. So this is the repetition. Okay, that is the first step whenever you are getting some word. First step is check if there are repetition letters and write and keep it separately. Next step is check how many letters are there in that word accountant. How many are there? First. How many are there? How many letters are there in the word accountant? 10. Yes. So now this question mark should give me one answer. That question mark should be, that is, you are arranging the word accountant. Okay, so here our answer is. So the answer is accountant. So number of ways, right? Number of ways the word can be arranged. So which is that word I'm not writing, okay? Number of ways the word can be arranged. Is. Yes, so it is 10 factorial. All the repetitions I have to divide. So A is repeated 2 times. So 2 factorial into 2 factorial into 2 factorial into 2 factorial. To be on the safer side, let us note down who was that 2. Okay, who is this 2? This 2 is A, this 2 is C, this 2 is N, this 2 is T. This is for us to understand. Because later we will be in trouble if we are not following which numbers that you are written there. Okay, anyone with the answer? Anyone with the answer? Yes. So here this is equal to 226800. Okay, 226800. Fine. Okay, now so one question out of this is over. Now there is another question here telling us in how many of them vowels are always together. Always together means what comes to my mind? Put them in one packet. But first let me check how many vowels are there. How many vowels are there in this? A is a vowel. Okay, so 1, 2, 3, 4 vowels? Yes? Okay, so let us do the second one now. Second one in this. So vowels are always together. So out of here, I think there are 10 letters. You all told me 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of this now, the vowels are A, O, U and A. So together means put them in one packet. Put them in one packet. So call this 1, 2, 3, 4, 5, 6, 7. Now you have to be very, very, very careful. So first let us do the 7 arrangement. 7 letters arrangement is 7 factorial divided by 2 factorial into 2 factorial into 2 factorial. Now I said this is very, very important. You need to understand who is that 2. This is outside now. I still did not go inside the packet. I am outside. So in the outside, remember A is already gone inside. So who is this 2 then? This 2 is a C. Okay. Then who is this 2? N. And this is T. So I just finished outside the packet. Now I'm going inside the packet. So into, move inside the packet. How many letters you can see? You can see 4 letters. And this 4 letters could be arranged in 4 factorial ways. Divided by, there is repetition inside the packet also. So which is that repetition now? It is A repetition and it is repeated 2 times. Is this clear to you? Is this clear? Yes, if anyone wants me to. Into. This is 12, not 24 by 2. So therefore, this answer is 7560. Okay? Write fast, okay? Find the number of permutations of the letters of the word Mississippi. MISSISSISSIPPI. MISSISSIPPI. Full stop. Full stop. In how many of these? In how many of these? A question. 4 S's are together. Here, no, these questions are lengthy, answers are small. Okay. Second question, 4 S's are not together. So whatever concept we have learned to know, that comes in this question. C is begin with MISS. D question is begin with SIP. Begin with SIP. Okay, so now don't waste time. Quickly, the word can be arranged. The word can be arranged in 11 letters are there. So 11 factorial by repetitions, 4 factorial, 4 factorial and 2 factorial. Who is this 4, 4 and 2? This is S, this is I and this is P. Always I write that for my safety. Okay? Yes. Okay. So go to A question, A answer. What is this telling us? 4 S's are together. S's are together means what? Put them in one packet. No. So first draw one line and write 11 lines. Draw one straight line and 11 markings you write. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now 4 S's are together. So here S, 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 S. They are together. Put them in one packet. So 1, 2, 3, 4, 5, 6, 7, 8. So this answer is, now quickly tell me what is your answer fast. This 34650 was the previous question, is it? This question? 11 factorial by 4 factorial? Yes. Okay. So it is 34650. Yes. Please note down the answer also. Okay. Coming to A now. It is 8 numbers. So 8 factorial. 8 factorial by, see I have not gone inside the packet, I am outside only. So which I have to write repetitions now. It is 4 factorial into 2 factorial. So let us make a note. Who was that 4 factorial? This 4 factorial was I, because S is gone inside, and this 2 is P. Into it is not over. Now go inside the packet. So when you go inside the packet, what you find? You find 4 S's. 4 S's can be arranged by 4 factorial, and since they are repeated, I am writing it. So this gets cancelled. Okay, that is A answer over. Now, what do you understand by the second question? Tell me, what is the second question telling you? Second question is telling you 4 S's are not together. That became the negative question. And when it becomes a negative question, what is the concept I have told you? Whenever it is becoming negative question, it is total minus positive question. And that total is already ready, positive is also ready. So my second answer is very, very easy. Yes, let us write the second one. Write 4 S's not together, 4 S's not together is equal to total minus 4 S's together. Positive is together. Kick out that word not. So you have that total answer. Total answer is 34650 minus, you have also 4 S's together answer, that is 840. Yes, someone give me this answer. 34650 minus 840. 33810. Write that answer. 33810. So this is B answer. Okay. Coming to C answer. Okay. Coming to C answer. Begin with MISS. So that is fixed now. Okay, so quickly draw one line and 11 letters. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is telling me it begins with MISS. So this is fixed. MISS. This is fixed. I'm not going to arrange, nor I'm putting them in one packet. They are fixed. Okay, so now I have to arrange only the remaining. So how many are there now? Arrangements. 1, 2, 3, 4, 5, 6 and a 7. Okay, so how many arrangements is possible here? How many arrangements is possible? This is 7 factorial. Okay, this is 7 factorial by. Now here, in this, you have to be little careful. It is, see, among this, okay, understand this please. Please listen, please see this screen. It is 7 letters, so 7 factorial. Now look here, in this S, there were 4 repetitions together, but 2 S are already fixed. How many more S is remaining is only 2. So only these 2 factorial, that is S, I am going to repeat. Okay, then what about I? One I has gone fixed. So how many more I is remaining is 3. So 3 factorial. Next, there was P. Yes, so both P's are there, so therefore it is 2 factorial. So quickly identify and write who is that, otherwise you may forget. So this is S, this is I, and this is P. Did you all understand why I wrote that 2 factorial? Because the S were 4. Out of that, 2 are already fixed. So only 2 are there to arrange. So 2 are repeated. Following, no? So out of I, 4 I's, 1 I is gone fixed. So only 3 are there. So therefore 3I factorial. Okay, and 2P, that is for P. Okay, yes. Give me this answer. 7 factorial by 2 factorial into 3 factorial into, is it 210? I want somebody to confirm. Yes, so it is 210. Yes, okay. And let us move to the last part here. Begin with SIP. Oh, yes. So now once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So begin with SIP. So here it is SIP. So this is also fixed. Okay, so now check how many are remaining. 1, 2, 3, 4. It is 7 factorial, Akshata, because MISS is not taken as 1. That is fixed. You are not arranging that at all. If somebody is fixed there, you are forgetting that person. Is that understood? Is that understood? Whenever you see, whenever I write that word fix, that means you're not considering. They're the same position. You are not going to keep them in some other position. They're in that same position. It begins and you have to keep it there. Same way with the D question here. SIP is fixed. Forget about that. You are just worried about who is there afterwards. So here it is 1, 2, 3, 4. 5, 6, 7, 8. 5, 6, 7, 8. So now attempt this question. So it is 8 factorial into. Now, yes, once again come here. S were 4. One S is fixed. So how many S remaining is 3? Okay. Next, I were 4. In that 1 is gone. So 1 more is 3 more are there. Next, P was 2. In that 1 is gone. So only 1. When 1 is there, I am not going to write. I'm not going to write. Make this idea clear. So this is S and this is I. Okay. Have you understood why I did not write P? Have you understood why I did not write P's repetition? Because out of 2P, 1 is gone fixed. Only 1 is remaining. For 1 remaining, it is not considered as repetition. Okay, so what is this answer? Is it 1120? 1120 is the fourth answer. Yes, I will give you 7th question. Find the number of permutations. Find the number of permutations. Find the number of permutations of the letters of the word. Write first. Of the letters of the word committee. COMMITTEE. Full stop. A question in this. How many of them? How many begin with the T and end with the T? How many begin with the T and end with the T? B question. In how many all vowels together? All vowels together. C question. Vowels not together. Okay, in short I wrote vowels not together. D question. End with MITE. And E question. No two vowels together. No two vowels together. Okay. So quickly find out from the word committee how many letters are there. How many letters are there? First, 1, 2, 3, 4, 5, 6, 7, 8, 9.